Hi friends, this is Datta and today we are going to learn SQL Server execution plan. When we say SQL Server execution plan, it means the way by which SQL Server engine execute or process the query physically. Okay, means I'm just writing one simple query as select all from one table as a test underscore plan where id equal to 1 means this is a query I have given to SQL Server to execute. Now SQL Server will prepare multiple choices or multiple ways to execute this query physically on the stored data. The test plan is a table in database containing data. So I am manipulating data within a table. So the query optimizer of SQL Server engine will think and will prepare multiple plans and multiple ways to execute to process this query, and which finalizes finally one of them which is a most cost effective. Okay, so cost of execution is lowest, then it will select that plan. That way means the plan of execution. So I will just execute this query and then I will show you result. Okay, so this is simple result of this simple query. And if you want to see how this query is actually processed by the SQL Server engine, then you have to go for SQL Server execution plan. Okay, there is a one button you can see over here in menu bar, the actual execution plan. I'm just pressing that button and I'm just executing the query again. You will see the execution plan of this query. So you can see over here, earlier there were only two tabs and now you can see the third tab is execution plan. As this query is very simple, this execution plan is also simple. It's containing only two parts as select and table scan. So these two components are called as logical and physical operators of query execution plan. There are like multiple and so many logical physical operators, but in this session we are going to see only few and mostly use physical operators of query execution plan. Okay, so we'll just go first. I will write it down one by one as we go further. First is select. Okay, you can see it is already being used over here, but it doesn't mean that select is used in every query. Okay, so it may not be necessary. So for insert and update delete, it is not necessary to use select. So second over here we can see is table scan. Okay, what means table scan? Maybe you have studied in college or textbook that table scan and table seek. Over here the same concept is applied, so I will just explain you in more depth what is a table scan. Table scan means reading all rows over tables. Okay, I have just asked the SQL Server query to return me the only one row from this table test plan which is having id is equal to 1, but the SQL Server has searched every row, every record from this table and returned me only one row. So this is a table scan. So as it is a scan means going through each and every records of the table, means you can see over here there are around 1 million records in this table. Okay, but he searched all of them. I will just show you how many records are there in this table. I'm just selecting by count function. You will see, okay, there is only one row in this table. I'll just select one more. I'm just pausing the video. Okay, I'm just running the count query and show you how many records are there in this table. You can see there are 1 million records in this table. Okay, so whenever I told the SQL server to execute the query and return the result only for id is equal to 1, and he searched all 1 million records, means it is not cost effective. So table scan is negative point. Okay, means whenever you see the table scan in execution plan, means you are wrong somewhere, you have to correct it. So how to correct it? If you want to avoid table scan, then you have to create index, means primary key or at least one clustered index on the table. So you may know that there will be only one text clustered index on table, means any table in SQL Server can have only one clustered index. So we'll create it and we'll show you what will be the result. I will just altering the table, alter table test plan, and adding constraint as primary key, constraint name as pk underscore test plan as primary key on id. Okay, there is one column as id, so I will just create it. You will see index is being created. So you can see what the SQL server internally does when I add primary key on existing table. You can see over here there are few operators. You can see it will go for first execution plan. One more important thing I want to tell you is whenever you want to read execution plan, read it right side to left side. It is exactly reverse how we read any book. Okay, so you have to start with extreme right operator. Extreme right operator over here is table scan, means he at first searched scan whole table, then sorted it. Means whenever you apply primary key on a table, internally it applies clustered index on the table. So for creating clustered index, he just sorted whatever you on row records were there in tables. So he sorted every records and given for the creating an index. So third over here operator is insert index, means after creating index it inserted every record from table to index. Means now physically the record are stored in leaf nodes of clustered index. Means now you can see over here earlier every record was in table and heap was data structure over there. Now the clustered index is data structure and the data of the table is stored in the leaf nodes of clustered index. So this is an index insert, and again its parallelism, means whatever operation done over here it has done it in parallel to optimize or to having minimum cost and minimum time. Parallelism minimizes the time but not cost. Okay, so cost is same because of parallelism. It has achieved the all tasks within a small amount of time, and afterward last is insert. So it is an insert statement for the inserting a table, inserting a records into index. Okay, so all this about the plan of creating a clustered primary key and clustered index. Okay, so we'll again fire select statement. I will just list it down whatever new operator we have just learned. Third one is insert. Okay, fourth one is parallelism. Parallelism just facilitate parallel operation in SQL Server to save our time. Fifth one is index insert. Index insert is of two type. Okay, one is cluster and another is non-cluster. Because the index over here is clustered index, which is already created within a primary key automatically, so over here the operation is clustered index insert. You can see over here the index insert and bracket, it is showing cluster. Okay, so again the sixth operator is sort. Okay, sorting. So sorting is internally applied. We have never mentioned over here order by clause, still the sorting is happened because it was need of that operation for creating index. Whenever we create clustered index, it rearranges data records physically on basis of given key column. Over here key column is id, so it has sorted all records on the basis of id and again inserted into cluster index. So physically rearrange the data on the basis of key column. Last one is table scan, which is earlier mentioned, so I will not mention that again. Okay, so I will again fire same query and select count star from test plan where id is equal to 1. You will see over here index seek. Earlier there was table scan. So what is difference between this index seek and table scan or index scan? Scan means checking each and every record for searching only one record. So it is costly. Means if the table is containing 1 million rows, I am searching for particular only one row, and it is unnecessarily checking every records of the table, means it's checking nearly about 1 million records for searching one. And seek is totally opposite, means he know already where that record is and he directly go and fetch that record. It means seek. Okay, he don't need to search each and every record to find particular record which I have requested. Why it happens seek? Because he already know that where that record is and the address of the physical address of that record, means the address of each and every record is somewhere saved. Okay, somewhere stored. So this is what index. Okay, because index is similar concept as index of a book. Okay, if don't have index on in a book, if you want to search any chapter, then you have to search each and every page of the book to find some particular content. Similar concept over here. Okay, so I'm just listing out one more physical and logical operator is, you can see in cluster index seek, physical operator is cluster index and logical also same. Physical operator showing the operation and logical operator showing the actual implementation. Seventh is cluster index seek. Okay, similarly I will create one non-clustered index on this table, on the column name. Okay, for this syntax is create index. I will specify over here non-clustered index name is ix underscore test underscore plan underscore name. On column table name is test plan and column name is name. Okay, so I'm just creating this index. Is something wrong? Create non-clustered index name on. The on keyword is missing, so giving error. So I'm just creating non-clustered index, and we'll see what is the effect of this query. We'll again show you execution plan of this query to create non-clustered index. You can see the similar plan as earlier. Over here you can see earlier there was table scan at rightmost operator, and now it is a index scan, because now data is not stored in heap and it's stored in clustered index. Whenever we create first clustered index on a table, the data records are stored in leaf nodes of index, clustered index. So it has searched first index scan and then given for sorting on the basis of name. Now you will say why it is need to sorting, because data is already sorted, but I have created non-clustered index on name column, but earlier data was sorted on basis of id, so it needs to be again sorted on the basis of name. Then this non-clustered index is created, and again parallelism, and finally is insert into that non-clustered index. So you can see this is a index insert non-clustered. So I will not mention over here because it's already mentioned. Now I will again fire same statement, select count star. I will just show you. I just fires one more statement with statistically difference is I will just operate on name. I will just filter on name as 1, and you will see what is the execution plan. You can see over here execution plan is having one more different operator as stream aggregate. Stream aggregate basically applies whenever we use aggregate functions like sum, count, mean and max. Okay, so over here we use count, so it applied aggregate, stream aggregate. I will just list it down. Okay, so you can see over here the index seek is optimal operation, means whenever you get table scan or index scan, you have to convert it into index seek to have optimal solution of the query. Okay, I will just fire one more query with little bit difference. I will modify existing query, and instead of equal to I will put like, and 1 I will apply percentage wildcard characters, and it will search all the records having 1 as a value into it. Okay, so instead of writing only 1, I will write 100. Okay, we'll see what happens. Okay, there are 1000 10,000 records are there having the value 100. Okay, and we'll see execution plan. Over here you can see the index can get appeared over here because though we know we have non-clustered index on column name, but it is not able to search name properly because this percent means wildcard characters, because we are going to search, we want to search the records having 100 as a string somewhere in between the name, not beginning and not the end. So this is very bad condition and we have to avoid it to achieve table seek, index seek. Okay, if you are going to use this condition, then you will see index scan every time. Okay, so to write optimal kind of code you have to avoid this. I'll just neglect one of them percent sign, and now the query will search all records having name starting with 100 and we'll see what is the result. It will return 101 and we'll see. You can see over here index seek happen, means either you have to use this wildcard character at the end or don't use it at all. But it is very bad practice to use character at the wildcard character for searching at both of the side of the string and searching the string. So it will lead us into index scan. So we just remove index scan and we convert it into index seek. Okay, string aggregate again same, and this is the compute scalar. Compute scalar mainly operates whenever there is some calculation issue. Okay, over here counting is a calculation part, so it applied compute scalar over here, and the select is again operator. So we saw multiple physical logical operators as select, compute scalars, index scan, index seek, and something like that. Okay, so we'll insert one more row and we'll see what will happen. Okay, so I will just create one more table over here. Create table T123 and I will give the column as ID and value as int. Okay, I'll just create it and insert one record value as 1 and I'll execute it. You will see the execution plan of this query. You will see the table insert operator. Okay, means whenever I have created one table, I have not applied any cluster index and I have inserted one row, then table insert operator appear. Okay, query optimizer uses table insert operator for this operation. So I will write it down again. Table scan, and this is for, okay, I will write it down at the end. Nine is table insert. Okay, now I will apply clustered index on this. Okay, so I will create index cluster index ix underscore t123 underscore id on table name t123 and column name as id. So we'll see the creating of cluster index. Cluster index get created and a similar plan as earlier. Table scan, then sorting, then index and set. Then I will insert one more row in this sample table. T123 value is 2. I will see the plan of this insert statement. Plan of insert statement is clustered index insert, means the value get inserted into clustered index. So this is a physical operator get appeared whenever we use insert statement on the table having clustered index. Okay, you can see the physical operation is clustered index insert and logical operation is insert. Okay, so sometimes you can see the physical operation is same as logical operation, but sometimes physical operator is different than logical operation. Okay, over here you can see the actual execution mode is row level. Okay, then actual number of rows are 1 because we inserted only one row. Okay, and other things you can get to know that actual number of batches is 0, and estimated operator cost is giving a cost in terms of IO and memory, estimated IO cost and estimated CPU cost and estimated subtree cost. So all these things are given in millisecond. Estimated number of execution is only 1, number of execution only 1, estimate number of rows 1, and exactly are also only 1. Because there is only one row in this table, you can see select all from table, and you will see there is only one row or two rows on this table, but we have operated on only one row. If I insert this third value, then again it will give us same execution plan. Okay, but plan are prepared on the basis of statistics update. Okay, means if you want to have accurate execution plan by the query optimizer, then the statistics of the database should be up to date. So you can achieve that by the command that auto update statistic on. So you have to set auto update statistics as on, and your database will be keep up to date statistics. Okay, then we study one more operator as joining operator. Okay, so we'll create two more tables and we'll join it, and we'll see plan of the query. Okay, so select all from employee inner join on department okay, I think department table is not exist over here, so I will just use another table as EMP. Okay, I will just change my database and I will get other tables. Okay, D. I will just see whether this table is already exist or no. Table is not exist. DEP. See EMP info. Okay, no issue. We have another table as EMP info. It will work as our next table of the join. I will put alias name as E2 and I will give on condition as e1 dot eid. What is there in employee? You see id equal to e2 dot id. Okay, this is a simple join query. We'll see what will be the execution plan of this query. You can see execution plan contains the table scan again, the index seek over here, because in table this is for one table, as this is for emp info and this is for employee. Since the employee table contains index, clustered index, so it goes for index seek to search that key values, and since the table emp info don't have clustered index, it is going for table scan. And over here this is the joining operators. You can see the physical operation is nested loop and logical operation is inner join. Means for logical operation inner join we have multiple physical operators available, and the query optimizer selected one of them as nested loop join. So what are others for joining operators? I will just list it down over here. 10 as join operator. Join operator is logical. Okay, it's logical, and for that available physical operators are, I will put it down in flower box, commented line multiple, comment for multiple line. Okay, this is a logical operation, and available physical operators are nested loop join or merge join or hash match join. Okay, there are, we will not go into depth, okay, but these are available option for joining operator. Okay, so over here it is selected nested loop. Then we'll see what is exactly the nested loop and what is means by merge and what is hash match. Okay, suppose there are two tables, okay, which is having 4 rows. I will just show you this in Excel. I will work on one Excel document over here. I will create two tables conceptually, and I will explain you what is nested loop. Okay, I will just increase font to make it visible. Okay, so what is the characteristics of nested loop join? I will just show you one table, okay, as emp over here containing columns as id and name and dep id. Okay, so one more table is department, okay, having dep id as one of the column and dep name as another column. Okay, the two table contain data as one employee ID name A and DP ID as 101. Department contain department ID is 101 and name D1. Okay, I'll just put some test records over here. Again, employee ID 2, employee name B, department ID 102, and I will have again department ID as 102 and name is D2. Again 103, department D3, and 104, department D4. I will insert some records or an employee. See, again it is for 101, 4th D 103. So over here, how it will work in nested loop join. For nested loop join, it will, as name suggests itself, it will go for looping. Okay, means it will take its first key value, because the common or joining column is department ID. Okay, because I will put on condition over here as DEP ID. Okay, equal to DEP ID. Okay, means E dot EMP dot EDP ID equal to department dot DEP ID. So whenever I write this joining condition, it will go for searching. Okay, it will go for searching this key values into both tables. Okay, so how it will go, I have highlighted first key value from 1 and more. Okay, so for nested loop, it will take one table and iterate through each and every record from other table. You can see the first record contain key value as 101. It will try to search at 101 in other table. It will find it first row. So the result will be, over here I will write result will be contain columns as ID, name, DEP ID from department. Okay, then from DEP ID from employee, this DEP ID from department, and this is a DEP name. Okay, so what will the result for first row is 1A 101 again, and name is D1. Similarly for next record, it will go for searching the second key value into another table of key value, key column. The key column is DEP ID, and it find the match at second row. So the result set will be, it will reflect in result set as 2, employee ID 2, employee name B, department ID 102, again department ID 102 from department table, and department name is D2. Okay, in this way it will search each and every record, key value for each and every record of left table into key value column of right table. Okay, so what is left and right? Whenever I write a join keyword in any query, so whatever be the tables written in left hand side of this keyword join are the left table, and right side table are right table. So result set will be like this. C 101 again, 101 again, and department is D1. For fourth record id 4, name D, again 103, searched in department table, it got in third record 103 and name is D3. So this is a inner join result. Nested loop for nested loop join. For merge, I will again go for another example. Okay, for merge I will put it on to next tab and give you example as merge join. Okay, for merge it will get sorted both tables on the basis of key value. Okay, means this is the left table, this is the right side table. I want to join it on the basis of department ID key column. Then it will go first searching for sorting operation. Over here the sorting will be done on the basis of key values. So left side table and right side table will be sorted on the basis of DPID. Over here it is already sorted right side table, but left side table is not sorted, so I will sort it down and this table will be as it is. So I will paste it over here and left side table will be sorted as it is just a matter of this row. So I will just copy this and paste it further over here, and I will copy record and put into sequence. So you can see now both tables are sorted on the basis of department ID, and how the result will be appear in result set is, if this is a result set, it will go for matching the both values and both key values. It will first search this key value into other side. Okay, it will just write it down by sequence. Okay, so it is searching this key value up to first only, because it don't have to go to search and read every record data, because he know that the records are already sorted. So after 102 10 will never come. Okay, over here also same, that after 101 repeated twice it can read it, as it just copy paste over here in result set and repeat first record of department table. But once 101 key value ends, he know that it will never appear again because it's already sorted. It is a prerequisite condition for merge join, so it will go for next key value. For next key value again it starts searching for second, because up to first record we ended up the first key value. For second it taken second, and afterward it sees that 102 is not exist, so it will stop searching. So another result set will contain the same thing as earlier, just it is more, this is a more optimal way in case that both record set or both tables are already sorted on the basis of key value given in join condition. Okay, this is a merge join. The then we'll see another type as hash match join. Okay, hash join. For hash join the concept is everything is same, only one difference is it will get appear, or this operator will get used whenever their joining key is much complex. Okay, means the DPID is much complex, like varchar value and much long, then it will apply hash function okay, to get some value, to generate a key value, and it create hash table in memory, okay, for this particular two tables. These are the input tables given for the joining, and hash match join will create hash table inside the memory with which will contain the respective key value generated by the hash function for this particular key values as 101, 102. Okay, so for every key value, hash function will create one hash value and it will get inserted in hash match hash table in memory. Okay, so it will be more simple for joining purpose. This is the concept is same, okay, but this is a hash join. Okay, we'll again return to our main query and go further. Okay, so that's about the table scan, index kick, index scan. This is a joining operator, this is select operator. Okay, and we'll see one more operator very important as lookup. Okay, so we'll see now lookup operator. I will just show you the example of lookup as select star from test plan table name where name equal to 1. Okay, I will select again the same database as earlier, and I will show you that plan will contain nested loop. It will seek, okay, why it is nested loop again, we'll just see. Okay, where name is equal to 1, it is go for index seek, and this is a key lookup. Over here you can see this is a key lookup. Why key lookup will appear? Because the lookups are of two types basically. I forgot to mention you the key lookup and RID loop. Basically lookups are bad in terms of performance, so we have to avoid it. Okay, so how we can avoid it? By creating covering index. Okay, so why there is lookup appears? Okay, because I will just show you why it get appear. There are 4 columns, 5 columns are there in table as ID, okay, comma name, comma GID, okay, and others. Okay, so I will just put over here current rate. Okay, so whenever I write this query, the key lookup get appeared, means I have index on column name which is getting used for searching the record of having name is equal to 1. It's correct, but my query is selecting columns as ID, name and current date. Okay, so there is issue, means whenever I select only one column as name, or there are only 2 columns as ID and name, then you can see over here the key lookup will not appear because there is index on name which is already being used for searching record, and ID is already stored in a clustered index, so there is no need for searching the another value. But whenever I write over here current date, the current date is not included in any of the index. Okay, so if I include this column in index which is getting used for searching this name, then it will key lookup will get avoided. Okay, so I will just show you how to use covering index. Okay, you can see over here on the table test plan there is one non-clustered index on the column name. Okay, so I will just drop this index and will create another index. Okay, so alter, or I will just drop index. This is syntax for dropping index. A drop index, index name, and on table as test underscore plan. I'll just drop it. We'll create index with same name but different parameter as create index, index name, on table name, and column name is name. Everything is same. I'm just including the name, column name, which is used in select clause and it was not earlier part of a query. So I will just create index. Okay, create index, index name. I'll just put non-clustered. Index, index name on test dot len. I will just put this in bracket. Include current date. I have created covering index for table column current date because it was not earlier part of that index, and it was, this column was getting used in select clause. I will just execute the same query again. We'll see the key lookup is not there. Okay, so key lookup result. So key lookup is bad point in terms of performance, so we have to avoid it. So how can we overcome key lookup or row id lookup? By using covering index. Okay, so row id lookup is a term used in terms of table. Okay, if there is no cluster index is at all there and only non-cluster indexes are available, but over here there is a cluster index created, so we got a row id, we got key lookup, and we also resolved it. Okay, so that's all for SQL Server execution plan, reading the execution plan, and we'll see in next video for reading a text plan and using SQL Server profiler tool and other tools for performance tuning of SQL Server queries. If you like my videos, please like and share my videos. Also subscribe my channel, and that's we'll stop for today. Bye bye. Thank you.